let's continue from our previous lecture. Okay. So we started on generating the solution of second-order non-homogeneous ODE, and we started on the method of undetermined coefficients. Okay. So here's a quick review of this so-called method of undetermined coefficient. This is the table, is basically the guideline that you use this method here, right? And this method here applies to second-order ODE with constant coefficients A, B, C. So what happens is you need to follow three rules. So those three rules here. The first one is called basic rule. Okay, so before we talk about the three rules, maybe I should mention that the general solution for this second-order homogeneous one is y equal to yh plus yp. Yh is the so-called complementary solution, which is basically the solution to the homogeneous second-order ODE. So you set this left side equal to 0, and the solution of that is yh. Yp is a solution, so-called particular solution, so that something is specifically fits this ODE here. Okay. So the whole question here is boils down to how do we find the yp. And the basic rule says you find your yp by giving an initial guess for the yp. The guess of the yp depends on the format of this function or the input f of t at here. If f of t takes any form in the first column in here, then your yp will pick correspondingly from this table. Okay, so that's your basic rule, right? Basic rule. And you have two other rules. Modification rule. Basically, you don't stop there. You have to look at specific situation here to look at whether you need to apply the second and the third rule or not. So the second rule is called the modification rule. Basically, saying is if yp duplicates one of the solution, okay, or even two of them, both of them, from this yh, then you need to multiply the yp with a constant t or t squared, depends on how many times it duplicates. If it duplicates once, multiply by t. Duplicates twice, multiply t squared. So we'll look at the situations, all right? The last one is summation rule. Basically, if f of t is a summation of, or it's addition of each one of this one here, then yp should also be a summation of those initial guesses that are here, right? So that's the three rules that are here, and you can 100% guarantee that this will be tested in the final exam, right? So make sure you understand this handouts that I gave it to you last lecture. Okay, so let's see. I'm not solving it, but let's give a couple of examples that are here. So let's say I have y prime minus 6y prime plus 8y equal to 3e to t. Maybe change this one a little bit here. Let's just start this first one here. Okay, this is the first one here. So here is the second order, and it's all constant coefficients here, right? Okay. So first step, okay, is always what you do is you basically lay down the characteristic equation, and this is lambda square minus 6 lambda plus 8, okay, equal to 0. So you need the solution for the lambda to get the expression for the yh. Okay, so for time being here, okay, so what's the lambda here? So if you don't remember the formula, if you remember the formula, you can plug in the formula capital lambda. Otherwise, you can always separate this 8 into different factors. In this case here, I can separate 8 into 2 and 4. Right, so this would be Okay, it'll be this. Okay, so one of the common mistake I have seen, or a very dangerous mistake, is people make a mistake right from the beginning, get the wrong lambda. You get the wrong lambda, so you know the whole thing will be wrong, right? So make sure you get the lambda right. Okay. Not only that you make sure lambda right, you also have to make sure that your YH is right. Okay. YH is C1 E lambda 1t plus C2 E lambda 2t. So one of the mistakes I've seen is the lambda here is 2, 4, right? So I've seen a mistake is C1 E negative 2 lambda t plus C2 E negative 4 lambda t. Okay. So that's also wrong, right? You know, you make this mistake here, the rest of the work will also be wrong. So make sure don't make this kind of mistake. Okay, so that's YH, right? That's YH. Now we're looking for the YP, right? So YP, as we said, we follow those 3 rules. The basic rule number 1 is we follow the basic rule. We take a guess from this table, and your input. Look at your input is 3E 3T. So basically, our guess would be this guy here, right? Be this. So we're gonna use the CE this. But make sure that if I use C1, C2 here, you're going to use a different constant from C1, C2, right? So your YP initial guess, so I guess I'll write it down here. YP is C1, C2 already, so let's use maybe A here, E, because this is 3T, so that's just 3T at here. So that's your initial guess of YP. And then what you're going to look at is you're going to have to look at whether you need to modify it or not, right? So that's the second rule, modification rule. So how do we modify that? We have to look at this initial guess and compare that with our basis of the solution at here. So you look at this one here. Do I need to modify this one? All right. Does this one, basically you ask yourself, does this one duplicate any one of this here, right? It doesn't. Okay, yeah. So in this case, basically, this is going to be our final guess. Okay? We don't need to apply any modification at here. Okay. And now what you do is, I'm not going to solve it yet. Okay, so we're going to leave it for short. So now what you're going to do, you're going to solve for this A at here, right? Solve for the A. So how do you solve for the A? So the general approach is you get YP prime first. So in this case, 3A. This, then you get your YP double prime. So YP double prime, the prime of this one here, so that'll be 9A this, right? Okay. Yeah. So then we substitute YP prime and YP double prime back into this differential equation here. So the general approach is this. So sub YP prime, YP double prime, okay, back into that differential equation, and try to solve for A. Okay, try to solve for A. Okay. Yeah, maybe let's see if we can solve this one here, right? Yeah. Let's try to solve this one. Okay, so if I try to solve for A, let's see what happens, huh? I'm gonna sub this one over here, sub this here, sub that over there. So what do I get? I got 9A E 3T here minus 6 YP prime, 6 by this guy, and plus 8 by this guy, so 8. Okay, so that's the left side. Okay. Equal to your right side, which is 3 of this. So solve for A, right? Solve for A. So this is actually easy because your left side here, there's a common factor e to the power 3t. The right side also has a common factor e to the power 3t. So that two things got cancelled, and we end up with what? 9A plus minus 18A plus 8A equal to 3. So what do we have? So 9 plus 8 is 17 minus 18 is 1A. So A equal to 3. Right? Yeah. So your yp is basically is a -3 e to the power of negative and e to the power of 3t. Right? So if you don't, if you want to verify it, just resubstitute back into differential equation and see if that's a particular solution. Right? Yeah. Is that good? Yeah. So that's the general approach here. Okay. Okay. So now if I slightly change this equation here, right? Yeah. So still the right side I'm going to keep the same thing. Yeah. So now this time I'm going to change this input to this. So 3e to the power of 2t. Okay. So the input is this guy here. Yeah. So if this is the case here, so you still do the same thing, right? Still do the same thing here. Okay. Characteristic equation, and yh is c1e2t, c2e4t. Okay, your yh. And you still do an initial guess, and yp, because this is 3e to the power 2t, so I'm getting a e to the power 2t. Okay, yeah, that's your initial guess. Yeah. So then you're gonna have to look back. Do I need to make a modification or not? Right? Whether you make a modification or not depends on what? Whether this one duplicates any one of this one here. So you look at this one here. Which one does it duplicate? This guy. See, this is E2t, this is E2t. So this term actually duplicates this term, right? Even though they got the same different constant, but they're general, right? So basically, a is some value. You're going to find it out. It's not going to be a general constant here. So basically, this term here is part of this one here, right? So if this duplicates this one and this one doesn't duplicate that one, so you're going to duplicate once. So then what we need to do is, so this one duplicates, okay, duplicate this one, okay? Okay, so then what we say is we can see the YP modification rule. So saying YP is AT e to t. Okay. Yeah. So this is going to be your final guess. Then we solve for the value of A. Alright? Yeah. So how do we do that? We still do the YP prime, YP double prime. Okay, I'm going to leave that to you for practice. Okay. Yeah. So here is one case of duplication. Now I could give you another case here. Y double prime minus 4y prime plus 4y equal to 3 e to the power of 3t. So same input as before. It's a slightly different system. Okay. Yeah. So y double prime minus 4y prime plus 4y. Okay, let's take this one here. Characteristic equation. Lambda square minus 4 lambda plus 4 equal to 0. Okay. So what's the solution for lambda? 2. So you have a double root set here, right? A double root. And when you have a double roots, what is the solution for this homogeneous one? YH, which is what? C1 E lambda T plus C2. That's right. Yeah. So you should memorize this in by heart here now. Okay? Okay, so this is your YH now, right? YH. And then we're going to take initial guess of YP based on this f of t at here. So initial guess YP. So initial guess based on this format. So A E 2t. Okay, A E 2 initial guess, right? Yeah. And look at the modification rule now. So when you look at the modification rule, we look at this. This guy duplicates this one, right? So we need to multiply this by t. So then becomes AT E2t. So after modification, you see again this t E2t again duplicates what? This term here. So we need to multiply a t again to make it the final guess of our yp here, particular solution. Was that clear? It's a little bit quiet here. Anyone's not clear here? Don't be shy though, huh? Yeah. So this one here not duplicating anymore. Okay, yeah. So this is your yp here. So your final guess. So you calculate yp prime, yp double prime, okay, and solve for A. Okay, solve for A. Was that clear? That's basically the general approach here. Okay. So you need to basically look at the situations. What under what situation that you will have these duplications here, right? Duplications. You need to make the modification summation rules. So let's take a look at another one here. Y double prime plus 9y equal to 5 e to the power t plus 2 sine 3t. Okay, so this one's different now. First of all, difference is the input side has two functions, right? So it's an addition of two functions here. And apparently, I think we're going to have to make use of the summation rule, right? The number 3 rule. Okay. But before we do that, we still need to do the initial groundwork, find the characteristic equation, okay, and find the roots. What is the roots for the lambda here? Plus minus what? Magnitude? Plus minus what? 3? Yeah, G3. Yeah. It's a complex number, huh? Now this is one of the mistakes I've seen before, you know, giving you such kind of question, and you give a positive negative 3, the rest of the thing I don't even have to look at anymore, right? Yeah. So J3, because this is lambda squared equal to negative 9. You know, positive number cannot be a negative number, so it has to be a complex number here. So if this is J3, what is the solution for this homogeneous one? So if positive negative J3, so the real term part, real part is 0, right? Real part is 0. There's only imaginary part. So your general solution here is cosine 3t. There's C1 here, plus C2 and what? Sine 3t, right? Okay. That's the general solution for the homogeneous one. Okay, so now back to our question here. Now we need to look for yp now, right? In the initial guess yp. So guess of yp based on the f of p, f of t here. F of t has two functions, okay? And so f of t, you can consider f of t as two functions, f1 of t plus f2 of t. Okay. So I guess my yp, it's like I'm gonna have two parts there too. So yp1 and yp2. So my initial guess yp1 is according to the f1t. My initial guess yp2 is going to be according to this f2t. Okay. So let's take a look at the initial guess for the yp1. IC1 correct to F1t. F1t is over here. So that's phi e to the power t. You look at your table, it's going to be a e t, right? And this doesn't duplicate any one of this one here. So I'll just pick it as it is. Okay. So yp2, okay, yp2, you pick yp2 according to 2 sine 3t. Okay, so according to the table, when you have a sine term, right, when you have a sine term here, so here, this one here, your choice of yp will be this one here, right? Choice of yp. So it doesn't matter whether it's a cosine or sine or a combination of sine and cosine, so it's going to be this. And omega here is 3, so my initial guess yp will be as the n cos 3t plus m sine 3t. So that's my initial guess, okay? Initial. So after initial step, you got to look at the modification rule here. So the question is, do we need to modify this yp2 or not? Yeah. So why is that? Because this yp2 duplicates which one? That's right. See, you see the yp here is exactly the same format as yh, right? So it duplicates. So you solve for n and m, it's going to be just part of this one here. So we need to modify it. Modify. So the yp2 is going to be multiply this initial guess by function t. So it's going to be nt cosine 3t plus mt sine 3t. Alright? That's it. So that's this yp2. So then the next work is to take a derivative, take another derivative, substitute back to this one here, solve for all the constants here. Right? So I'll show you how to solve this constant here, but that's the general approach though. Is that clear regarding this table there, particularly this modification rule? Okay? Yeah. If I test you, it's not going to be as blank as where is it? It's not going to be as blank as this one here. Okay? So if I test you, I need to test all the knowledge point here. Chances are you need to be careful regarding this modification rule here. Right? Any questions? Good? Okay, so now let's take a look at a few more examples here, okay, in terms of solving this. Okay, so let's pick a good example. Okay, let's try to solve this one here. Y double prime plus 4y equal to at squared. Alright, first characteristic equation. Give us a lambda positive and negative J2, which give us YH. Pretty straightforward. Alright, so then this is step 1. Now step 2 is we need to find the yp now, right? Yp, you take your initial guess based on 8t squared. 80 squared. So you go back to the table. 8t squared, that's the formality of this function over here. N at here is 2. So you need to pick your yp according to this one. Okay? Yeah. Alright, so now that means my yp is going to be k2 t squared plus k1 t plus k naught. Okay, that's the yp at here. Maybe just a quick reason here. Maybe you should ask it, why do we pick the yp like this, right? Why not something else? So there's a reason in it here. You look at this one here. When you take a derivative of e to the power of alpha t, what do you get? you get alpha e over t. You take a derivative again, what do you get? You get alpha squared e over t. So basically, you always get what is something multiplied by e to the power of t, right? See, that's why the only variation by taking derivative of the exponential one here is always something by e over t. So that's why your choice yp is just simply like that. How about this guy here? If you have a t to the power of n, or let's say t to the power of 2, right? What is the derivative of t to the power of 2? It's 2t, right? And what's the derivative of 2t? Is 2, right? And then what is 2? Is 0. And there's nothing else now, right? So basically, the variations of this derivative of t to the power of something, it's this. See that, right? Yeah. And each one of this, t to the power of n, they actually also called linear independent. See those things, linear independent. If they are linear dependent, when you add two things together, they're actually gone. Okay. How about the cosine sine? When you take a derivative of sine cosine, all the variations you got is what? It's going to be either cosine or sine. So that's why you have this addition of the cosine sine here. Okay. Yeah. So there's the reason behind this one here. Okay. You call it lucky guess, but it's not that kind of lucky. You know, right? Yeah. Okay. So here's yp here. So yp prime. Okay, capital YP prime, which is 2k2t plus k1. YP double prime is 2k2. And I'm going to sub these three things back into this differential equation. Sub YP double prime, and YP prime. Okay, YP double prime back into this one. So let's see, what do we get? So YP double prime is 2k2. So 2k2 plus 4 by y. So 4 by this guy here. Okay, that's it. Then 8 equal to this 8t squared. Okay, t squared. Yeah. Plus 2. There's no plus 2, right? See, yp is this. Yp prime is 2t this, right? Plus k1. This is gone. Then yp double prime is derivative of this. 2k2 derivative. Yeah. Okay. Yeah. Okay. So then at here, what you do is you group similar terms. Okay, group similar terms. So group similar. Let's see, what do I have? We have 4k2 t squared. There's only one term of this, so let's just leave it as is. And I have 4k1 t. So that's only one term regarding the t. So I'm going to just keep this as it is. And there are two constant terms. One is 4k0 and the other is 2k2. Okay, overall this equal to 8t squared. Alright. Okay. So the reason we do this one here is basically you're trying to solve for k0, k1, k2, right? So how do we solve the three things here? Essentially you compare the coefficients of the right side with the coefficients of the left side. So look at this right side here is 8t squared plus 0t plus 0. So then comparing coefficient, meaning what do I have? I have 4k2 equal to 8 and 4k1 equal to 0, and that 4k0 plus 2k2 equal to 0. Okay, so this is just the way to compare the coefficients here. And this is very simple here. So this second one here basically means k1 equal to 0, right? And k2 equal to 2. You plug a 2 into the last one that is here, and you can solve for the k0. So 2 over here is 4, plugging there negative, so negative 1. k0 is -1. Okay, so that's how you solve for this constant here. Essentially, Doesn't matter what kind of function taking here, whether it's at squared or maybe sine or cosine. So all you need to do is, after you're substituting the yp double prime, yp prime, and what you do, you group the similar term, compare the coefficient of the left side with the coefficient of the right side, all right, and then solve for the constants here. And if you feel that you're shorting of one equation or somehow, there must be a certain mistakes there, okay, and it's guaranteed that you can solve though. So that means this yp equal to 2t squared minus 1. Then general solution is y equal to yh plus yp, and that equal to c1, what was it again? C1 cosine 2t plus c2 sine 2t plus 2t squared minus 1, right? Okay, so that's the solution here. Now, you probably will have an initial value problem, right? So let's say maybe what you're giving here is y of 0 maybe equal to 1, let's say, just for example. And y prime of 0 maybe equal to 0. Just come out. Maybe it should work. Okay. So let's use these two initial conditions here to solve for the C1 and the C2. Right? So here's a common mistake. I've seen in the past is people solving C1, C2 based on the initial condition without putting this term here. So they start to solve C1, C2 by just plugging into this, basically the homogeneous one, trying to solve this. Okay. So, but what you need to do is you need to basically solve this C1, C2 based on the whole thing right here, right? Yeah. So what do? Let's say we solve for the y0 of 1. So what we do is we plug in this initial condition into this one here. So y of 0, okay, equal plugging t equal to 0. So t equal to 0, cosine 0 is 1, c1, and sine 0 is 0. So there's no c2. 0 into the t0, so minus 1, that equal to 1. So which means c1 is 2. Okay. Okay. Yeah, some of the common numbers, I think you got to remember this. Sine pi over 2 equal to 1, right? The midterm here. I've seen at least 5 to 10 students just, either made a mistake equal to 0, or they leave it as sine pi equal to 2. Which is actually not bad if you leave it as sine pi over 2. But if you equal to 0, then you made a mistake, right? So those common numbers, sine or cosine common numbers, and you got to be able to know it. It's not using calculators. And also some of the common integrations, like one of the midterm here, integrate over cosine. At least maybe 5 or between 5 and 10 students. They equal to what? Negative sine x, right? So that kind of mistakes, in my mind, is inexcusable, right? You cannot say I don't have a formula sheet. You don't need a formula sheet, right? This kind of thing here. Yeah, you're gonna get fired if you go to work. You see your boss asks you what's the integral of cosine, right? No kidding though. So anyway, so that's C1 here. C2, you need to calculate the y prime first, right? Y prime first. So calculating y prime here, that's negative 2c1 sine 2t, and plus 2c2 cosine 2t plus 4t. Yeah, same to this e to the power of negative, let's say 2 tau. 1/2 to tau, right? That 5 to 10, which is not that bad. They equal to 1/2. of this, right? So you make this kind of mistake, right? So please don't make this kind of mistake though. Because sometimes I pick this integral purposely to be very simple ones. I know because sometimes you probably having trouble for very complicated ones here. So for this one here, okay, so y prime 0, plugging 0 over here. So first term is 0, second term is 1, so 2c2 plus 4, 0 equal to 0. So that means c2 equal to 0. Right. So the key point here is when you solve for initial value problem, when you calculate yp prime, when you calculate the y prime, make sure you're doing it with respect to this whole general solution, not just the yh at here, right? Yeah. Okay, any questions? All good? All right, so let's look at one more at here, okay? So I'm not going to be able to cover all the examples in lecture notes, and I hope you're going to look it over and to see some more examples there, right? So this is the second order differential equation here. The left side input is 4 cos 10t plus, not plus, minus 190 sine t. Okay, 190 sine t. Okay, just coming to, I need to emphasize a little more here, okay? When I say integral, I think I mentioned this in 248. This is not an integral. You gotta have this whatever that you're integrating with dummy variables, right? Yeah. So make sure you write everything properly. Okay, so here is this second order one here. Now, first step. Okay, characteristic equation of the homogeneous and solve for lambda. And the lambda you solve here. Okay, this one you probably want to use the formula. Okay, it's -1 plus minus j2. So basically, this is your alpha, and this is your beta. So which means my yh is e to the power of alpha t. So e to the power of negative et, e to the power of negative t, and cosine 2t plus c1 here, c2 sine 2t. Okay. So that's the general solution for the homogeneous one, yh. Second step, so yp. So we solve for yp by taking initial guess first. Our initial guess is based on the input at here. So look at the input here is there are 2, right? There are 4 cosine 10t, negative 190 sine 10t. So your initial impression is I've got 2 there, maybe I should use addition rule. But however, you look at this one here, both of them are what? Have the same frequency, 10t. Okay, 10. So basically actually means both of them are in the same format, even if they are one is cosine, one is sine. So when you take your initial guess actually you only need one of them, which is n cos 10t plus m sine 10t, right? So that's enough. Okay. Unless here is a cosine phi t, that's sine phi t, sine 10t, then you're gonna have maybe n1 cos 10t, m1 sine 10, then n2 cos phi t, m2 sine phi t. Right? Yeah. Is that clear? Yeah. Okay. So I need to solve for n and m, but before we do that, the question is: do we need to modify this yp based on the modification rule or not? So does this duplicate any one of this one here? No, right? Yeah. So what we do is, okay, maybe okay, what if this is not 2 here? What if this is 10 at here? Would you still call it duplication? If this is 10 here, think so? No, because you have this one here. Okay? Yeah. Because you have an e to the power negative t here. Okay. So even if it's 10, 10 here, this is not going to be duplications. Right? Okay, so here is my final guess. And I'm going to calculate yp prime and I calculate yp double prime. So calculate yp prime 10n, so negative 10m, okay, and yp double prime, so be careful with this thing here, and that's going to be negative 100 minus 100. Okay, yp prime, yeah, so it's a relatively long expression. Now we sub this yp prime, yp double prime back into differential equation, right? So sub the 3 at here back into here, okay, back into here, and group similar terms. So when you sub this one here, let's say this term goes here, that term goes here, and this term goes there. Okay, after substitution, group the same, basically group all the cosine, group all the sine, right? So if I do that, what I'm going to get is negative 100n plus 20m plus 5n, okay, cosine 10t, and plus negative 100m minus 20n plus 50, no 50, and 5m sine 10t. So that's the left side, and equal to the right side, which is 40 cos 10t minus 190 sine 10t, right? Okay, so group all the similar term, compare coefficients, right? Compare coefficients. So compare these coefficients with this, and compare these coefficients with this. Don't forget a negative sign there. So 110n plus 20m plus 5n equal 40. Next one is 100. This is 100. M minus 20n plus 5m negative 90. Alright, so solving two equation, two unknowns, right? Two equation, two unknowns. And by the way, these are two unknowns, so you can combine the two n's here and two m terms here, right? So that'll give you m, n, m is 2, and n is 0. So the answer is quite simple. Okay. So that gives us this solution yp, which is the 2 sine 10t. Right. So it doesn't matter how complicated the system it is, huh? Just be careful when you do this prime, double prime, and a substitution and combination things here. Okay, so if there is a situation, basically. Last case here, okay. Let's say for the same problem, okay, for the same problem here, let's say this is y double prime plus 2y prime plus 5y equal, okay. So we have this 40 cos 10t minus 190 sine t, the original problem here, right? So now suppose I have, okay, an extra term over here, okay. Suppose I have extra term here. So now this is basically the case that you need to make the summation rule, right? The sum rule, right? The third rule. When you solve this kind of problem here, my suggestion is you follow this. So you have here this is your f of t, and this is your basically f1 of t, and this is your f2 of t, right? Yeah. What we just did is what we solve is we just solve this equal to f2 of t, right? What we just did this. So when you have a situation like that, separate this differential equation into like two parts. So you're basically solving, one is this, okay, and the other is like solving this one here. Okay, it's like this. So from this one here, you got your yp. Let's say let us call it yp2. Okay. So from this one, you got your yp2. From here, you got your yp1. Right. So yp2 is the same as this 2 sine 10t. So the only question is, how do we, what would be the yp1, right? So you obtain the yp1, but it's actually very simple, you know, same approach, right? Same approach. Then overall, your yp is the yp1 plus yp2. Okay? Yeah. So solving it separately, okay? Solving separately. Instead of solving separately, if you think you're very neat, okay, you're being careful, you can also solving all together. So which basically means what? You take your initial guess yp as a whole chunk of this expression here, right? Then you take yp prime, yp double prime, sub this back into this original one there, and solve for all the constants at the same time. Okay? Yeah, sometimes it's going to be a very long expression, you know, you write very long, right? But this is kind of you can reduce the number of errors. Any questions?
I was just wondering, do we have quizzes this week for 246?
Oh, no. All right. We have 2 more quizzes to go, and they're going to be in the last 2 weeks of this term, right? Yeah. So basically, the last 2 weeks of this month. Okay. Yeah. Thank you.
Just thought I'd check.
Thanks for remembering.
Yeah.
No problem. How are you?
Good.
Yes.